Okay, today is 5.4, day 2. It's more about how to solve tougher quadratics, and sometimes when the quadratics have variables thrown in. But right now, I'm trying to remind you of how we did these. Would you agree that this number, if it's going to be greater than that number there, if it was negative, it would always be true? Just think about it for a second. Wouldn't something in an absolute value that comes out have to be positive and therefore have to be bigger than negative 5? Okay. What if I said it had to be bigger than m? Then what could you tell me about m? Let's start with equal to. I think it'll be easier. Let's start with equal to. An absolute value is equal to m. And what do you know about m? M is positive. How do you say that with math? There you go. M is greater than or equal to 0. Okay, awesome. So what if I said this is 2m plus 5? Then what equation could you write? Exactly. Solve that. Negative 2.5. Raise your hand if you got that one right. Okay, good. Now, you have to figure it out at tonight's homework. What if I make this less than that? Or what if I make this greater than that? You'll have to figure out the ramifications. Not going to tell you. Just like, if I just tell you all the answers, you aren't going to learn near as much as if you struggle with it and figure it out. Okay? Shouldn't be long and painful struggle, but the other thing that you had to do today that involves some painful struggle for some of you is probably figuring out the tennis ball lab. And once you know the secret, which I'm not telling you yet, it's really not that hard. You just have to solve an equation, and you can use a calculator, so graphing works great. All right, so for this next test, another topic that you're supposed to be good at is absolute value of 3x minus 4 is less than 5. Is that always going to be true? Is an absolute value like that always going to come out less than 5? No. So you can solve it and find out when it would. Remember, this breaks into 2 equations. Go ahead, give that one a try. I'll pause for a second while you do that. All right, so did you say 3x minus 4 is less than 5? And 3x minus 4 is greater than negative 5? Okay, good. Then you solve the 2. 3x is less than, adding 4 makes 9. X is less than 3. And adding 4 here, 3x is greater than negative 1. X is greater than negative 1/3. Now, if I left it that, you guys left it that way, I'd cry a little bit and mark it wrong, because that's not one of the formats that we have. One of the accepted formats is number line, where you'd have negative 1/3 here, and bigger than this, and less than the 3, like that. And there we go. That's an acceptable format. Or this. What would ever make this so that it is brackets? If it said or equal to. All right. Yes, except, okay, so here's the question. Can you say that as negative 1/3 is less than x is less than 3? Yes, as long as you sandwiched it in with this. X where, and you need one of these and one of these, but a lot of people forget that. Then you haven't given the format. That one's called set builder notation. All right, so that was the easy one. But then a lot of you got to this kind. And you knew to factor it, because if you can factor it, you should. But then everybody was saying, well, I shouldn't say that. People were asking me, should I set x plus 3 greater than or equal to 0 and x plus 1 greater than or equal to 0? And the answer, of course, is no, by the way I'm saying it. You can't do that. All you can do is set them equal to 0 and solve those. So, of course, we got x equals negative 3 and x equals negative 1. Do you get that those two are important spots? Those are the roots, the zeros. Yes. Go ahead. So, if you are now going to graph this, you know negative 3 is important and you know negative 1 is important. But how do you know where to actually shade? All right, here's the hint. Is this or is this not a U shape? It's a parabola. There's no negative. It's a U shape. Do you get then if it's a U shape and these are the x-intercepts, the roots, the zeros, that it would look something like that? Okay. So then the question is, where is this green line below, above or equal to 0? Shade in the parts of the green line that are above or equal to 0. Hint, this is the line y equals 0 along here. Please tell me you knew that this is where it's above 0 and that's where it's above 0, right? Okay, so then how would you say that with intervals? Negative infinity is correct. Negative 3, and then what's in between them? Union, and then negative 1, 2, infinity. Good. There you go. Okay, brackets versus parentheses. So, it says or equal to here. What does that make you think? It should be closed in holes. Very good. And therefore, brackets. Nice catch. I was actually intending to talk about that and then forgot about it. So that is really easy way to lose at minimum partial credit. At minimum 5%. Boom. Okay. Math rewards careful people. I've been a little off my carefulness game today because it's been a little bit crazy with the Halloween stuff going on. So I made 2 mistakes. One in first hour and one in your hour right there. Okay. Let's see if I can hold it together for a few more problems here. Okay, so what if you had to solve this? Notice the negative. And it's not going to factor. Run me through the steps. What's the first thing you think? If you can factor it, you should. Well, I can't factor, so now what? You need to know that follow-up. If you can factor, you should. If you can't factor, quadratic formula. Now let's figure out what the heck that means when you get your quadratic formula and yet you have to give your answer on a number line. You're finding these points. Last time they were really nice, like negative 3 and negative 1 or whatever. Now it's not so nice. I'm going to pause for a second while you try to figure those out. Okay, let's see. Did you say x equals negative 2 plus or minus square root of b squared, which is 4 minus 4a, which is negative 1, c all over 2 times negative 1. Okay, so there it is. It's just kind of gross, but then when you're done with it, the smaller one goes here and the bigger one goes there. So let's finish it up a little bit. Do you get that there's 3 negatives in there, which makes it negative? And therefore 4 minus 4 makes 0. So this whole thing becomes 0. And therefore it's just that. Which means that looks like that vertex formula, which means we're at the vertex. Yes. And what is x? X is, let's see, it's negative 2 over negative 2, which makes positive 1. So there's only one line at 1. So x equals 1? Yes. Now, what shape is the parabola? Is it a U shape or a mountain shape? Mountain shape. How am I going to do it when there's only one dot? Just touches right there. So now, where is this function less than or equal to 0? Always is the right answer. Very good. So the question was, where is this function less than or equal to 0? So where is this function here below 0? Well, pretty much all the time. What about the spot where it touches? That's where it's equal to 0. So it even works then. So the answer is all reals. All right, so let's say it was a graph. Let's say it was a normal graph, and let's say I had a parabola that was touching like this. It's just we don't have a y-axis. This is the only thing, because you don't really need one. Yes? Okay, you can factor it. You're correct. And it would have been easier to factor it if you take out a -1, and then you'd have x squared minus 2x plus 1, and then it would factor to x minus 1 and x minus 1. Which makes 1. So either way, I would have got 1 as my root. All right, let's do one more like that. Where is x squared plus 6x plus 5 less than 0? Charlie Brown, that's true. That's a good one. Okay. Sorry, we were just talking about good Halloween movies that are not super scary. All right. X plus 5, x plus 1. I hope this was in your happy place. Very easy to do. You got -5, you got -1. And now the question really is, where do you shade? Let me show you a new technique. Imagine for a moment, since this is Halloween, that you've been locked in the basement by an evil math teacher. And he's not going to let you out until you've answered this question properly. And if you get it wrong, you have to do 10 more. You're like, dang it, I really want to get this one right. So how could you check and see? You think you're supposed to shade on the outsides, but you're not sure. How can you check and see if you're right? Well, I would recommend testing. What's a number that's between -1 and -5? Like -2 or -3, doesn't really matter. Doesn't have to be perfectly exactly in between them. So if I stick in -2, watch what happens, please. That's +3. That's -1. That makes, when you multiply them, -3. Is -3 less than 0? It worked. Wait a minute. I thought that area didn't work, and it turns out it does. So now I'm rethinking everything, my entire life. No, I'm just rethinking this part and this part. Maybe it's in here. Okay, so now I should probably check something over here, see if it works there. Like -7, sure. If I stick in -7 right here and right here, that's called testing an interval, and kids are terrible at it. I have checked tests like this forever, and everybody gets the roots right. Everybody will get that it factors and you get these two things, and everybody gets that right. It's the testing of intervals that people are terrible at. So let me show you one. Let's say you got it factored down to this. And I'd like you, 0, sorry. We always want to set them compared to 0. I'd like you to test the intervals to see. I know you're all going to get the roots right, but shade in the area that you think works by testing the intervals. I'll pause while you try that. Okay, here we go. Everybody knows that this is -5 and this is 4, so that everybody gets right, and they all circle them. But whether or not you fill in the circles and where you shade is a different item. Okay, so should I fill in circles or not? No, because if you wanted to check one like 4, if I actually put in 4, it will make it equal 0 because of this part right here becomes 0, Is 0 greater than 0? No. And so it does not work there, so it should be an empty circle. So this is, again, testing intervals. And then I'm going to test something bigger than 4, like 5. And if I put in a 5 here and here, it'll be 10 and 1, and that's 10 times 1 is 10, is bigger than 0 for sure. I was right. It's shaded on the outside. Yay. Okay. Because when you put in -6, or what did you put in? I'll take -6 then. -6 and -6. This is -1. This is -10. What's a -1 times a -10? +10. Is +10 bigger than 0? Yes, it is. That's why it works out there. So again, kids are usually terrible at testing intervals. So I have a better way. What did I say before? To sketch it on here. Is it a U or a mountain? It's a U. Would it ever be a mountain? There was a negative out front like this. Okay, but there isn't one. So it's a U shape, so it goes like this. So when is the U bigger than 0? In here and in here. So now, some of you guys are going to like the graph better, and I think, honestly, if you get that, it's easier. But testing intervals is great, too. So I'm fine with either method, but you need to know where to shade. All right. Now, last thing is I need to throw in some variables. Like, let's say, instead of just x squared plus 5x, let's say it's rx plus 7. So my question is, I know you know the vertex formula. It's negative b over what? 2a. But what about in this case? It's still negative b over 2a, but hopefully you'll be able to figure out what b is, and then you'll have the x. Then you'll have to figure out the y value of the vertex. Find the vertex. Go. And don't be freaked out when your answer has an r in it. That's kind of the point. So here we go. Negative b is negative r. Over 2a is, well, a is still 1 here. The a term is 1. The b term is r. The c term is 7. Okay, so it's negative b, which is negative r, over 2a, which is 2 times 1. So it's negative r over 2. What is that, though? That's the x. We're trying to find the vertex. So here's the vertex. What comma what? We just found out that it's negative r over 2 for the x. Then you go and stick that in to the equation. If you didn't already understand what we were doing up until now, at least maybe you understand now that you're just supposed to find the vertex, and that's the x of it. Go stick that in here and simplify it down, and you'll have it. I'll give you another minute to figure that out. Figure out the y of the vertex now. Okay, so should have had negative r over 2 squared, which is really r squared over 4, plus r times negative r over 2, which makes negative r squared over 2. And then it's plus 7. Now, granted, you could put all these together with a common denominator, but I don't feel like I'm really up to it this hour. So if you did it, awesome. I'll show you real quick. Then it's negative r squared over 4 plus negative r squared over 2 plus 7 over 1. And then you multiply this one by 2 over 2. And this one by 4 and 4. You're right. It's positive. Thank you. Okay. And then I would have r squared minus 2r squared would be negative r squared over 4. And then this is 7 times 4 is 28. So you'd have had 28 minus r squared over 4 if you actually put that all together into one fraction. Okay, but that'd be a lot. I don't think anybody probably actually did that. But the moral of the story is, can they throw in a variable? Oh, yes, they can. All right, let's find the homework for today. Everybody look for this set. I'm having you skip this one. Don't think you need to do this one. And on the next page, I think all of these are good. And you're going to realize that, oh, it's just a quadratic, and they tell you a number to stick into it. And then you got to also factor in, I didn't notice this before, that it's between 0 and 35. That means x can only go up to 35. That's the biggest it can be. And that's, maybe they've only got 35 bottles of the organic Sasquatch tonic. All right, so anyway, this profit obviously goes in there into P for profit, and then it's just solve an equation. And that, hopefully that looks kind of familiar. Oh, wait, it says at least. So negative x squared plus 25x minus 100 has to be at least 50. How do I write that? Oh, and there is the 10-minute warning. Stop that. Okay, so greater than or equal to 50. Actually, that's the 12-minute warning. So, okay, so these three, that's a good start there on 33. Just want to show you, they just boil down to, look, it's a quadratic again. If you want to graph both sides and see where they cross, that's an option. I personally would subtract 50 and get it greater than or equal to 0, because then it's always easier to tell when your graphs are like, ooh, where is it below 0? It's really easy to tell. Okay. In this case, it would be where is it above, because this is greater than 0. All right, and then if I go to this page, these are the kind that have a variable in them. And I did talk to you about this earlier. Remember me saying that if you have, let's say this said equals, then we would know that ax plus 1 has to be greater than or equal to 0, because that's what absolute values do. They come out positive, which is also known as greater than or equal to 0. Actually, they come out, I shouldn't say they come out positive. Absolute value of it come out not negative, because you can be 0. All right, so anyway, giving you that hint for this last page. So that's it, and that's all I got for you for today.